Chapter 6, Lesson 3, Rotations. You will be able to graph rotations on the coordinate plane. Okay, a rotation is a transformation in which a figure is rotated or turned about a fixed point. In this case, our fixed point is the origin. Complete the following problems. Graph triangle LMN with vertices L 53, M 55, and N 12. Then graph the image of triangle ABC after a rotation of 180 degrees about the origin. Write the coordinates of its vertices. The first thing I'm going to do is label my quadrants here. We label our quadrants. The top right is quadrant 1, and we move counterclockwise. Quadrant 2, 3, and 4. And yes, you must use Roman numerals. Okay, so let's plot these points. 5, 3. 5, 5 is M, and 1, 2 is N. Go ahead and use a ruler and connect those points to get your triangle. Okay. Now we are rotating 180 degrees. Each quadrant represents 90 degrees, simply because that's a right angle. Here's another right angle, and another, and another. These are all 90 degrees or right angles. So if this were 0 degrees here, to rotate it 90 degrees would mean to move to the quadrant to the left. We rotate the same direction that our quadrants are labeled. So if we're rotating 90 degrees, 180 degrees, and 270 degrees. So in this case, we're rotating 180 degrees. That means I move 90, 180, and I'm going to put a star here. That's where this triangle will end up. It'll end up in this quadrant, quadrant 3. So I want you to notice this triangle right now is in quadrant 1. And just if it lies in a couple quadrants, then focus on just one singular point. So we'll focus on point M. Point M is in quadrant 1. I need point M to be in quadrant 3. So what I'm going to do is I'm going to rotate my paper so that this star is my new quadrant 1. So again, point M is in quadrant 1, so this star, I'm going to rotate the paper until that star is my new quadrant 1. So everything is upside down. That's okay. I'm going to pretend this is my new quadrant 1. I'm going to replot these points. So L is 5, 3, 5, 3, and I'm going to label it L prime. It's okay that it's upside down. M is 5, 5. I will label it M prime. And N is 1, 2. And I'll label it N prime. Go ahead and make your triangle. Okay. And what I want you to do now is put your paper right side up. Now what we have done is we have taken this triangle, okay, and we have rotated it, not 90, but 180 degrees. Okay. So now I want the real coordinates of the image. So we have L prime, M prime, and N prime. I'm back to normal. I have quadrant 1 in its appropriate place. So L prime is here, which would be negative 5, negative 3. M prime would be negative 5, negative 5. And N prime would be negative 1, negative 2. Let's take a look at B. Quadrilateral KLMN with vertices K23, L51, M4, 2, and N1, 1. Then graph the image of quadrilateral KLMN after a rotation of 90 degrees about the origin. All this means, these words about the origin, means that your focal or fixed point is at the origin. Then find the coordinates of the vertices of the rotated image. So again, I'm going to label my quadrants 1, 2, 3, and 4. And let's plot these points. 2, 3 is K. L is 5, 1. And M is 1, -1. And N is, oops, sorry, this is N. And M is 4, -2. I skipped one, not on purpose. This one's M. Okay. So here we have a quadrilateral. Go ahead and connect those points to make the quadrilateral. Okay. Now this figure is spread into two quadrants. Okay. Let's focus on right here, quadrant 4. Let's focus on just M. We want to rotate 90 degrees. Okay. So if I'm focusing on quadrant M, and I want to, on point M, and I want to rotate this 90 degrees, it moves only one quadrant. So I'm going to star this quadrant. So I need point M to move to this quadrant. Notice how point M is in quadrant 4. That means I have to move my star, rotate the paper in other words, until the star is in quadrant 4. So now the star is in quadrant 4, my new pretend quadrant 4. Now we can replot all these points. K is 2, 3. L is 5, 1. M is 4, -2. These are all primes. N is 1, -1. Connect those points. And rotate your paper so that it is right side up. The quadrilaterals may look a little different and a little skewed, but they are the same quadrilateral. Now let's find the real coordinates of our image. K prime, L prime, M prime, and N prime. K prime is -3, +2. L prime is -1, +5. M prime is 2, 4. And N prime is 1, 1. Letter C. Triangle PQR has vertices P, 1, 5, Q, 3, 7, and R, 4, -1. Graph the figure in its rotation of 270 degrees about the origin. Then find the coordinates of the reflected image. Oh, this should say of the rotated image. Okay. So labeling my quadrants 1, 2, 3, and 4. P is at 1, 5. Q is at 3, 7. and r is at 4, -1. Connect your points to make your triangle. Okay. We want to rotate 270 degrees, so let's pick a point to focus on. Doesn't matter which point. I'll focus on P. 270. Well, P is in quadrant 1, so quadrant 2 would be 90, 180, 270. So this is where I want my star. P is in quadrant 1. I need to rotate the paper until the star is in quadrant 1. So I'll rotate 90, 180, 270 degrees. And let's replot these points. P is 1, 5. So P prime. Q is 3, 7. So this is Q prime. And R is 4, -1. So this is R prime. And go ahead and create your image by connecting the points. And put your paper right side up. Now let's label our new points. P prime, Q prime, and R prime. P prime is right here. Looks like 5, -1. Q prime is 7, -3. R prime is -1, -4. Now there are actual rules that we can follow for our rotations. Personally, I like to actually rotate the paper. I think it's easier. I don't have to memorize any rules. But here are the rules. For a 90-degree rotation, we have a capital R and 90 degrees as a subscript. 180-degree rotation, there's the notation. And 270-degree rotation, there's the notation. So we take our point x, y. And if you look here, what happens is the x and the y switch, but the y is negated. Now, that doesn't mean the y becomes negative. It means the opposite of what it was. So for example, we have 1, 2. We switch the two numbers, but then change this value to its opposite, which is -2. So let's do a couple of those. The first thing to do for a rotation of 90 degrees is to switch the numbers. That's the first thing. And then we negate the first number, which means change it to its opposite. Let's do it again. Switch the two numbers and negate the first term. Okay. 180-degree rotation is a little simpler. The x and the y stay in the same place, but they're both negated, meaning they're both changed to their opposite. So our point 1, 2 would be changed to -1, -2. So again, they stay in the same order. However, they're negated. So the -1 becomes +1, and the 7 becomes -7. I'm going to erase that positive sign. Again, we keep them in the same order, but we negate them. 8 becomes -8, and -6 becomes +6. "270-degree rotation, you switch them again, but this time the second one is negated. So here we have 1, 2. We switch them, but we negate the second one. So let's switch them. -2, -4. But we negate the second one, which means that -4 becomes +4. Next one, we switch them, but we negate the second one. However, 0 is neither negative or positive, so this one just stays as 9, 0.